Social media networks have gained very large user bases in recent years, and an enormous amount of user data is collected. This is Meta, which is the new name for Facebook, their 2021 results report showing that they have more than 3.5 billion users across their family of apps, which includes Facebook, Instagram, Messenger, and WhatsApp. Recent regulations, such as GDPR, give users the right to obtain a copy of their personal information. However, there is no way for the average consumer to gain useful insights into this data. This is an example of a data file that one might obtain from Instagram, and these data files are cumbersome and technical, preventing many users from viewing or understanding their data. Existing transparency enhancing tools, this being one of them, provide a poor user experience and are very limited in scope. This specific one only allows users to view their location history and YouTube watch history. This presentation proposes a new application which solves the problem by providing users with a web-based interface that's accessible to non-technical users, allowing them to view and analyze their social media data. This increases transparency about the data stored and also provides users with insights into their personal usage of different online platforms. I'm now going to show briefly how a user can go about obtaining their data from two companies, Google and Instagram. So for Google, a user can simply go to takeout.google.com and select the services which they wish to export data from and choose how they'd like to download it, whether they want it sent to the email or get it on cloud, how frequently they would like to download it, or if it's just a once-off, and the file type that they would like. And then once you click Create Export, Google processes your request and sends you an email link to download it. And I've done that for my own personal files, and this is the zip file they gave me contained this takeout folder, which then has a directory inside of it for each of the services you chose to export. And then for each service, there's a few files in there in different formats across the different services containing the data that you requested. For Instagram, you can go to Settings and Privacy and Security, and then scroll down to Data Download, where you can click Request Download and choose the format and put your email in, and again they send you an email with a link to download your data. And again, I've done this for my own personal account, and these were all the files that they sent me. And now in order to demonstrate this without exposing my own personal details, I've copied these files and then changed the data in them to automatically generated fake data, but still in the same structure. And that's what these are. And I'm now going to briefly demonstrate the application using these demo files. So if I select all of those and copy them into the application in the bottom left there, it'll start processing them. And now we can look through and see the visualizations that it creates from the data. So this is the account history for a fake Instagram account, and this is what the raw data would look like, just quite a few nested JSON objects in a list, and it's parsed that and displayed it then in a table, which has some benefits over just looking at the raw data, such as in the JSON file it just gives you ISO compliant language code and ISO compliant date timestamp and a quite long user agent string. And then in the visualization that's displayed to the user, the language is displayed as an English readable language name and a nice date and time that can be read by a non-technical user, and then the device is also given rather than the user agent string, and so that just makes it easier to actually understand what the data contains, and users can also resize the table or swap the columns around to suit their preferences. Now for the Instagram posts file, so this is loading the images in and displaying the captions, and this display style is quite similar to Instagram's own display feed for the posts. So this isn't much of an improvement over Instagram, what they already offer. But then in addition to just displaying the posts, it also does some analysis, the first of which is frequency tables. And what this is doing is counting the occurrences of the most commonly occurring words within the captions of the Instagram posts. Um, and this might be interesting for users to see what words they use most commonly in their posts. And it also does the same for hashtags, mentions, and emojis, which also might be interesting for users to see what emoji they use most commonly. The same type of analysis can be applied to WhatsApp chats or Telegram chats, and so it can be used across different service exports. The next type of analysis is time series, and what this does is it looks for a timestamp in the data, and then if it finds a list of timestamps, it can extract that and perform some aggregation on it. So up top here, this is just a bar chart showing for a period of time how many, in this case, posts were made per day, but it could be videos watched on YouTube or songs listened to on Spotify. And then below that, it's aggregated it by the day of week and by the month of year. And again, this might be interesting for users to see what day of the week they use a certain service more, or which month of the year they had the most usage. And then it's got a heat map right at the bottom showing rows for each of the days of the week and columns for each month, and then colored in darker where they've used the service more. The next type of analysis that's performed on the data is topic extraction. And now what this is doing is finding words that commonly appear together and grouping them as topics. So it's found 5 topics in this data, and unfortunately it doesn't display very well for randomly generated data. This topic extraction algorithm works much better for real human data, but nevertheless it displays how the feature works, that it extracts the topics and then shows the posts under each tab which match that topic the best. And this could be quite interesting for users to see if they either post different topics on Instagram, or if they see which topics they watch the most on YouTube, or which topics they listen to the podcasts of the most, and so on. Now, the way this is actually implemented is using Go, written in Go, and then compiled to WebAssembly, and that runs in the browser because the algorithm to perform the topic extraction is very computationally intensive, so it could take quite a while in a slower language like JavaScript, but using WebAssembly, it's fast enough to not be too much of an issue when using the website, at least with reasonable data sizes. If you get very large, kind of more than 20 megabytes, then it starts to slow down quite a bit. And then finally, the user can also access the JSON data and the raw data of the files that they've uploaded. Now in this case, this file is originally a JSON file, so the JSON tab isn't very helpful, but in the case where they've uploaded, say, a HTML file that has been interpreted, then the JSON might be quite useful if they want to perform some additional analysis on top of what's already available in this interface. Another feature of the application is that it has been packaged as a PWA, which is Progressive Web Application. And what that does is it allows users to install it through Google Chrome and then use it offline without accessing it through the web. So you can see in the top right corner of Chrome in the address bar, it's got a little install icon, and a user can click that, click install, and now it's no longer running inside Chrome, but it's installed as its own application, kind of just with a packaged version of Chrome that's already on your computer. And this allows users to then access it when their computer is not connected to the internet, which is something that perhaps users might want to do with their personal data to ensure the privacy of it, that it's not being sent to a remote server. The way that's handled in the application is that web workers are used to process their data in different threads of the browser without ever sending their data to a remote server for processing or storage. And this just guarantees privacy for the user, that they know their data won't be used for other purposes. And so having the Progressive Web app is quite nice for that. And you'll also notice in the top right there's this little green icon to show that they're currently online, and that adjusts based on whether their computer's connected to the internet or not. So I can demonstrate that by switching my Wi-Fi off, and you see that little dot goes red and says offline, and so that just guarantees that there's nothing being sent to a remote server, because the application can still work perfectly while disconnected from the internet. And then if I reconnect, it goes green again to show that now I'm online. And next to the online icon, there's a link to the GitHub repository. And this also helps with trust of the application, that a user can verify the source code for themselves to see that there's no malicious processing of their data and that it's all as they would expect. The source code's public, so it can be verified by any expert or user who's interested to see it. And you'll also see on the GitHub repository there's a MIT license which allows other developers to potentially extend the application if they wish to add a feature or to modify it in some way for a different purpose. And also in the GitHub repository there's this directory of testing, and one of the types of tests that was used in the application to try and reduce the amount of bugs and to make it a more reliable application is browser tests, which is also known as end-to-end testing, where the testing framework, in this case Playwright, would spin up an instance of the application and then load various pages on it and perform some testing to make sure that it's performing as expected. And I've got a video of one of those tests running to demonstrate this in action. So this is the testing engine opening a browser, loading in some files on the left hand side there, and then cycling through them, clicking on each tab to make sure the visualizations are displayed correctly. And it goes quite quickly through them because it can verify a lot faster than a human that the correct text is being displayed. And then it takes a screenshot as well of each tab that it opens, so the developer can manually verify that they were displaying what they should. So these are some of the screenshots that is taken of all the different tabs that it opened. And these tests are run on every commit to the Git repository to make sure that no bugs creep in over time, and that if they do, that they're fixed quickly. So you can see here Travis CI has run the test on the latest commit. And next to each commit it shows a green tick if the commit passed the tests, or a red cross if it failed, and then that just brings it to the developer's attention so that it can be fixed as soon as possible. And that concludes my presentation of the application. I hope you found it interesting, and please do give it a try with your own data and test it out for yourself. You might be quite interested at what you find stored in your own data. Not all of it is obvious from the service provider's own interface. For example, here in the Instagram data, they've got some inferred emails that you wouldn't otherwise be able to see on Instagram's own website, but you can see in this interface. So give it a try, and yep, I hope you find it useful. Thank you.